Alright, so let's jump into 3.7, number 7. You didn't really include in the picture what exactly the instructions were. So I just kind of started doing stuff here. Just try to make sure that you include that with every picture, so I know that so I know what I'm doing. But then we get kind of a standstill here at this point. So looking at it again, maybe we'd want to take a 4 out of here and an x squared out of here. So then we'd have x squared times x plus 4. It's greater than or equal to, and then we'd bring out that 4, and we'd be left with x plus 4. So this is looking really good. We can now divide by x plus 4 on both sides, and that'll get rid of those. Okay. Oops. All right. Okay, so that gets rid of those. And we just have left, let's see, what do we have left? Well, we have x squared is greater than or equal to 4. So that means x is greater than, and the reason that is because we're taking the square root of both sides. Okay. So x is now greater than or equal to 2, right? Plus or minus 2. Cool. Alright, so moving on. Let's see, we got number 29. Number 29 here. I think you, again, didn't provide me with any real information on what I'm doing. So I kind of just moved on to number 39. So let's see, number 39, it's basically, it says find all the values of x for where the graph f lies above the graph g. So if f is going to be above g, then we have this here. F of x is greater than g of x. So all we do is plug these functions in. Okay, so I did that, and now I'm multiplying by x on both sides. Okay, and that gets rid of the x over there. Now we're going to divide by 4. So now we have x squared is greater than 1. And then we can just, 1/4. And then we can take the square root of both sides. And then we go ahead and just get that x is greater than 1/2. Okay. Alright, so that is all of the x's. Everything bigger than 1/2. Those are all of the x's that you can plug into both of those, and f of x will be greater than g of x. I mean, if you think about it, you plug in something greater than 1/2, 1. Well, 4 times 1 is 4. And then you plug it into g of x, 1 over 1 is 1. Is 4 greater than 1? Sure is. So it works. Cool. Alright, so let's go ahead and move on to number 44. We're supposed to find the domain of the function. Okay, so when you're approaching these, you're basically saying, okay, well, domain, they want me to find the domain, and, well, the domain is everything that x can equal, and I know that I can't have any negatives inside of a square root. So I know that everything inside of that square root has to be bigger than 0. So I set it up as such. Say everything inside of that square root has to be bigger than 0. And then, those are all the x's I'm allowed to plug in, as long as all that stuff is bigger than 0. Because, again, we can't have negatives inside of exponents. So I'm just going through and solving. Here, I just factor out an x squared out of both of these terms. And I'm left with x squared times x squared minus 5 is greater than -4. Okay. And now we set these, we kind of do these separately, okay? We set them equal separately. So that's why I have that set equal, and that I've tried to color code it here for you. We set them up separately and solve from there, okay? So we know that this one can't be it because x squared is greater than negative 4. Basically, we don't want negatives in there, so we're not looking at that one. So our domain is going to be everything that's bigger than 1. So basically, we can plug anything that's greater than 1 into this thing up here, and we'll get something that's bigger than 0, which is good. So that means our domain is from 1 to infinity. Cool. Alright, number 49. Let's see. Cool, so number 49. Just go ahead and we're supposed to use a graphing device, so go ahead and graph it. Alright. So now all we're doing is basically solving for x. We're going to divide by x cubed, divide by 5. Now we get x is less than 8/5. Okay? Cool. So our interval is all the way from negative infinity because x has to be less than 8/5. So we're taking everything less than 8/5 all the way up until 8/5. So from negative infinity all the way up until 8/5. Sweet.